Hi, this is KSQD 90.7 Weekly Cutting Edge. I'm your host, Galina Hale, Professor of Economics at UCSC and Faculty Director at the Institute for Social Transformation. My guest today is Sandy Faber, who is a University Professor Emerita at the University of California, Santa Cruz, and also a member of the Lick Observatory. She's an observational astronomer with research interests in cosmology and galaxy formation. In 1984, she and three colleagues presented the first detailed theoretical model for structure formation in the universe based on cold dark matter, which became the standard paradigm for galaxy and cluster formation. She published over 800 papers and received so many awards that they take 2 pages on her vita. She received the National Medal of Science from President Obama in 2013. And since retirement, she has not stopped working really hard. She founded the Earth Futures Institute and the Osterbrook Graduate Leadership Program for Astronomy PhD students at UCSC. She's working to help humanity understand the perils and prospects for intelligent life on a finite planet, on both human and cosmic timescales. It's such an honor and pleasure to welcome you today, Sandy.
Thank you so much, Kalina. I'm so glad to be here. It's a pleasure.
So let's talk about astronomy. How did you decide? At what age did you decide that you want to study the universe? And how did that work out for you? And how did you end up at Harvard studying an astronomy PhD program?
I think I really got interested in the universe at age 5, but I got interested in a lot of science things. I kept records of weather. I had a microscope. I was interested in spiders and bugs. But as I entered college, I went to Swarthmore College on the East Coast. I was kind of divided between, well, I knew I wanted to study the universe somehow, but I didn't know whether I should study it in the large, like galaxies, planets, and stars, or whether the important thing was to understand the rules of physics that govern the universe, in which case I maybe should be studying particle physics or something like that. And I started out with chemistry. That was on the small scale. I didn't like that. And Swarthmore had an observatory, and I started to observe photographic plates that were being used to discover planets. They didn't discover any, but I was so enchanted sitting there at the telescope at 3 at night, listening to crickets and wondering as I looked through the telescope, is anybody looking back at me at the other end? So I kind of fell in love with astronomy in the large. Yeah.
And so back then, when you started at Harvard, were there any other women in your PhD program in astronomy?
Yes, as it happens, my year there was another woman named Catherine Cesarsky, and she is even more famous than I am. She is living in France, and she is very high up in the government of the European Union. She has been director of the European Southern Observatory, which is an amazing observatory, and so on. So as it happens, there were 2 of us, and both of us did quite well.
But did you feel any kind of, I guess, discomfort being in what otherwise people would think is a boys' club?
Well, I hate to say this, but I was usually the best student, so I think it was the boys that felt more intimidated than vice versa. The things that I've ran into at that early age were practical. So we postponed, by the way, I met my husband Andy at Swarthmore, so they call it the Quaker Matchbox. So anyway, we postponed having children till I finished my PhD. But I got pregnant very soon after as an assistant professor, and there was no maternity leave in the University of California. So I went to my director, Bob Kraft, who was an absolute prince of an individual. And he said, yeah, we don't have any rules here, but you just go off and do what you need to do, and we won't tell anybody, and we'll arrange your teaching, which could be controlled, but I still had observatory duty. And he said, just forget about all of that until you're comfortable. But, when somebody is giving you a gift like that, you don't want to abuse it. And I was the first female staff member at Lick Observatory, so I felt as I was a symbol of some kind. So with both children, I was off full time for 2 weeks and half time for 4 weeks, and then back at work after just a month, that was not an easy thing to do. And I was breastfeeding actually.
Wow. And I imagine observatory work is a night work. So does it mean
Well,
your
that could be
husband had to?
scheduled. I don't have to observe every night, so
Right.
that was one of the things that was more easily handled. It was all the other stuff. Yeah.
So I read your bio, and there are a lot of things I don't understand about astronomy. So I understand observational astronomy. Have you discovered any astronomical entities in your career?
My grad student, Robert Jackson, and I, back in 1972, discovered the first rule for the structure of galaxies. It's called the Faber-Jackson rule, and it relates the orbital speed to the mass of the galaxy. A bunch of these rules have been discovered after that, and they're clues to galaxy formation. Soon after that, I worked with 6 other people. I'm sort of famous for leading teams. So this one got named the Seven Samurai because it rode into town and demolished some cherished notions about the expansion of the universe. What we discovered was that there were large scale flows that were being induced by big clusters of matter. The expansion's very uneven. And then I started to work with the Hubble Space Telescope and led a team called the Nuker team. And that team was the team that established that there's a big black hole at the center of every galaxy, massive black hole.
Oh, wow. I learned that at school.
Yeah, right. Yeah, so
That's
those are some of
amazing.
the high points of discoveries in the universe that pleased me very much at the time. It's great.
Was there some part of your work that you can pinpoint as the most fun in terms of either research activities or discoveries?
The most intense, maybe I won't say fun, but as I said a minute ago, I got involved with a team that built the first camera for the Hubble telescope. And you may recall that the Hubble telescope didn't work at the
I
time.
did not know
You
that.
did not know that? Yeah.
Yeah.
It was a real embarrassment for NASA, this very expensive telescope that was supposed to take these beautiful pictures, and the images were no good. And all the standard optical experts didn't know why. They couldn't figure it out. But I was on the team that had this camera, so we took pictures, we analyzed the pictures, and my postdoc and I were the guys who diagnosed what was wrong with Hubble. So I would
Wow.
say that was the most intense detective work of my career. The whole press, media were watching from the outside. They were waiting for these images. NASA was stalling, news blackout. It was very politically intense period of time. This was the year 1990
How
when
did you
Hubble.
get drawn into this work?
I got invited to join the wide field camera team. I didn't build the camera. I had really nothing to do with building it or designing it. The team was allocated quite a lot of observing time, and they wanted to get some team members to help them do scientific analysis. And so that's how I happened to join the team. And as it happened, then it fell to me and my postdoc, who, by the way, John Holtzman, had been my graduate student at Santa Cruz. So there were
Okay.
actually 2 Santa Cruz people who diagnosed what was wrong with Hubble.
So what was wrong?
What happened was the Hubble telescope, like many telescopes, has 2 mirrors. And one of them was correctly figured, but the main mirror had the wrong shape. And how did that possibly happen, you ask? It happened because they needed a test optic to figure the right shape, and they made an error in assembling the test optic and didn't know that at the time. So they figured the wrong. It was a beautifully smooth mirror. It was just the wrong shape. It didn't match the other mirror.
Wow. And so were they able to replace it? They had to send astronauts to replace it?
They had built a copy of the camera. The camera was so important that for insurance purposes. They built a copy just in case something failed with the first one. So
Mhm.
it was sitting on the shelf, and it turned out that its optics could be modified to accommodate the error in the telescope itself. And then there were several other instruments that had to be reconfigured as well. It took them 3 years to build these corrections. And then there was a rescue mission that went up and installed these new instruments, and it all worked. It's beautiful. It's brilliant. Hubble
Wow.
is still
So
up there working.
yeah. So instead of fixing the error, you basically compensated for
It
the error
compensates.
with all the other.
We used to say Hubble got glasses.
Oh, yeah. That's a great analogy.
Right.
Wow. I was always fascinated by astronomy. I just couldn't remember all the facts. I guess I
Well,
didn't have the best teachers.
that's rather sad.
Yeah, I know.
But
Well, so
that's kind of how I feel about economics, Galina.
well, that's why we have so much fun talking to each other. So
Right.
let's talk about the Earth Future Institute. What is it and why is it?
Okay, so you've been kind enough to ask me about all the astronomy things that I've done. As I got older, I began to ask myself, why is this important? I really did think it was important. Important for human beings, not for Sandy Faber.
Mhm.
Why does humankind need this knowledge? And I think the reason is that you need to know where you came from in order to understand where you're going. As I got farther along in my career, I began to ask myself why this knowledge about the universe was really important for human beings. And I really do think it is important. And the reason is that we should understand how we got here, what was important, what are the laws of physics that allow us to exist. I don't believe in miracles. And I do think that our species has to live within the limits of the planet. So astronomy is just part of understanding our situation,
Mhm.
its promises, its opportunities, but also its limitations. So
Mhm.
Earth Futures Institute, as I thought of it, was designed to help us think, really, where can we go in the future, given that we live on a finite planet, we don't have infinite amounts of energy, materials, et cetera, et cetera. Okay, so as I began to think even further, I began to think about economic growth, which economists like to think is going to be exponential, like 3% a year, relentlessly every year, 2 to 3%. And as an astronomer thinking on cosmic time, it doesn't take like 30 seconds to understand that this has to stop
Right.
because, over 1 million years, if we last that long, we'll just be 10,000, a million times bigger than the planet can supply.
Mhm.
So that I think is a very interesting problem that I really wish we were all at Santa Cruz thinking about it more deeply, because we're going to have to make a transition. It should be as graceful and as benign as possible. How are we going to make that transition away from growth? And in the long term, here's the question that's really bugging me right now. In the long term, how many people living well can the earth support? A lot of my friends who are anti-growth think that we really went wrong when we invented agriculture, and we went even more wrong when we invented the Industrial Revolution. But
Mhm.
frankly, as a woman, I welcome some degree of science for the medical care that it provides. I really would prefer to give birth in a well-equipped hospital rather than out in the bush as women used to do, and some women
Right.
still do. So I asked myself, that requires a certain foundation of
Mhm.
technology to support that kind of life. Um, how many people can exist on our planet over long times living at that relatively high level of GDP per capita?
Right. Or if GDP per capita is even the right measure. There
Right.
recently, even economics turned into better measurements of happiness and welfare, and they're not necessarily all highly correlated with GDP.
That's very true. I think probably a better index is energy per capita,
Mm-hmm.
because I think energy is what makes everything happen.
Right.
And
Energy broadly defined in terms of all the things we eat and the things energy we spend to live happy, you're going to be able to move.
yeah, energy that it takes to run those machines that get copper out of the ground.
Right, right, right,
Mhm.
right.
Yeah.
No, these are great questions, and I do read quite a bit of fantasy and sci-fi novels. And in many of them, if action is happening thousands of years in the future, there is no economic growth, and the Earth doesn't have 20 billion people on it. So something, when writers imagine the world that's kind of possible in the future, they imagine something that's drastically different from what, economic models are not designed to project that far in the future. So I think economists also understand we can't grow forever. That's just not possible.
Mm.
Either they don't think in a global sense or they don't think in a 1,000-year sense. And so everything, even what we call general equilibrium, is really not that general from the point of view of questions that you are asking.
Do you mind my asking you a
Yeah.
question about
Yeah. Go
economists?
ahead. Yeah.
Okay. So, uh, yes, I understand that the models are not supposed to be that long-lived. But let's imagine that fossil fuels are peaking,
Mm-hmm.
not coal, but oil and maybe
Mm-hmm.
natural gas. Some people want to say it's here now with regard to oil. Some people say maybe a decade, 2 decades at most. And oil and gas are very important. Then don't you think economists, even with their more shortened time scale, ought to be telling us how we're going to tweak our economy? Will it be able to continue to grow if these really important energy sources begin to peak and maybe even dwindle?
Yeah. So I think absolutely. I think people think about it. It goes back to Malthus, right? The
Yes,
multi-billion
exactly.
paradox, because you
Mhm.
have a fixed factor effectively, right? In Malthus' world, that was land.
Yes.
He was saying we can't grow population beyond whatever it was in 1890s because agriculture can only produce so much. And we
Yeah.
found ways to intensify agriculture and grow 10 times of what Malthus thought the limit was. So that technological innovation allowed the land to be a lot more productive. Now, a lot of my friends in animal welfare world say, oh, we should have never done that because that is absolutely cruel system that is providing nutrition now for what is now 8 billion people on the planet.
Right.
So I would say a lot of economists would tell you, well, we'll figure out how to use the oil and gas more efficiently. We're going to use that to produce solar panels and wind turbines and batteries. So the same drop of oil goes further because of all the technological innovation. I think most economists will tell you that. We do, now even the textbook in macroeconomics that David Romer at UC Berkeley authored for graduate students, the chapter on economic growth has a limiting factor environment. So you can think of that as resources or, clean air is a resource that we're also are using up. And so people are thinking about that and what kind of technological growth would it require to maintain the final economic growth at a certain rate that you want. Or, maybe the growth doesn't have to continue. And I think in that sense, and we've had these conversations before, that um, capitalism maybe is not a system that's consistent with a lack of economic growth,
Yeah, that's
right?
my belief.
right?
Mhm.
But the capitalism only exists for like last 200 years, right? So I think when people say, well, it will have to be capitalism that is going to solve our climate problems and our inequality problems, I think it's a lack of imagination in some extent, because if you were in 1700s, you wouldn't imagine capitalism as a system,
Mhm.
right? So why are we assuming that the humanity is not going to develop a new system that's more consistent with sustainable growth or lack of sustainable existence, happy existence of human on this world? You need a combination of imagination and knowledge, I think, to think about those issues.
Well, you put your finger exactly on the question that I think and wish economists were doing, namely, it's not too soon to think about another system.
Mm-hmm.
And as you very well know, you go online, you read about capitalism. What is it? And the very first thing that people mention is it's free markets.
Mm-hmm.
But actually, we've had markets for thousands of years, which have been generally free, really.
Mm-hmm.
And so I think capitalism is all about capital. It's not so much about free markets. We could retain free markets,
Mm-hmm.
but have a different way of allocating capital. And of course, we attract it now through the allure of growth. But if there's no growth, then what is going to be the allocation mechanism for our capital resources?
Mm-hmm.
Yeah.
Yeah. I think people define capital also in different ways. In like
Mm.
recent decades, people talk more about intellectual capital or intangible capital, your know-how, your patents, your branding.
Yeah.
That doesn't require any physical resources. So I think another way economists can get out of the conundrum, which you're so clearly identified, is to just relabel some, relabel some things. We're pretty good at that.
Yeah. Well, another sort of allied argument that I run into is the service economy.
Mm-hmm.
But when you actually think about all of this, if somebody earns $1, they very often want to spend it on a car. And the minute you spend it on a car, then you're talking about stuff that comes out of the ground and energy that it took to make it. So, in some sense, the foundation of everything we do is the material world.
Well, also, I wonder if that has to be that way because we are in this world of conspicuous consumption, and there's this ultra wealthy individuals that compare their rockets. But maybe it doesn't have to be that way. And I see some kids, like in my son's generation, that don't want to own a lot of things. They don't want to own the house. They don't want to own more than two pairs of shoes.
Yeah. We need a new ethic about what
Yeah,
is status, not owning more stuff, but doing good things, doing good
I
work.
know. I'm so glad you said that. We need to make people who do good things famous rather than people who have lots of things.
Well, I'll tell you a story. We were just in Portland visiting our younger daughter and their two grandkids. And guess what? The activity of the weekend was thrifting. These
Hmm.
young guys, age 14, 15, 16, their fun was going out to thrift shops.
Hmm.
This is a huge activity, at least in Portland, I'd never thought about before, but kids are doing that.
Oh yeah, no, I love next door. That's where I get most of my stuff.
Yeah.
Uh, all right. Well, I want to go back to things that you are doing these days. So, can you talk a little bit more about the graduate leadership program that you founded in the astronomy department?
Yeah. Okay. So it was kind of similar to thinking about Earth Futures Institute. I find as I'm getting into my 60s, 70s, and now 80s that my dad's words ring in my ear, Sandra, make yourself useful. So I'm thinking about that in all different kinds of contexts, including graduate education, including astronomy graduate education. So when you think about it, the way we educate astronomers, not just at Santa Cruz, but everywhere, is really not focused on what will help society. We create good astronomers, true, but half of our people these days go into other fields, which I think is great because we're giving them quantitative training, analytical abilities, which they can bring to whatever they do. That's wonderful. But even our astronomers, they're PhDs, they're sort of an elite label there, and they wind up being presidents of universities, George Blumenthal, our chancellor, for example, etc. So the thing that we're not training at all, we're training them to go observe, do theory, write papers. We're not training them at all for these leadership challenges that may come their way later in life.
I see.
And the idea occurred to me that maybe we could take 5 or 10% of their time, not a huge chunk of their time, and expose them, first of all, to the fact that they will probably encounter this. Nobody told me this as a graduate student. That I wasn't encouraged at all to think about the fact that I would ever be a leader. So point number one, you will probably be a leader, especially if you embrace that. And then what does good leadership consist of? Let's talk to some people who have been experienced. The high point of our program is going off to Baltimore and Washington and interviewing tons of people who have astronomical degrees who don't work for universities. Some of them work for NASA, but they're bureaucrats at the NSF. They work in the Office of Science and Technology Policy. So we're lining up a trip this spring. We'll probably talk to 35 people who are not faculty members. And people find this very enlightening. You know, what is it that I can think about doing, and what are the problems that I could get engaged in, given my astronomical degree? It's really sort of mind opening more than anything else.
Yeah, true. I think especially for kids from academic families. I had a research assistant at the San Francisco Fed who came from a very academic family, and she was always going to do a PhD in economics. And then as the time approached for her to apply, she came to my office and she said, I don't want to do a PhD in economics. What else is there? It was, yes, the rest of the world.
I see. Very good. Yes.
All right. I think we're pretty much running out of time. I'm going to cut this. So don't get out of Zoom. I'm just going to stop recording. I want to chat with you for a couple of minutes after. But I'm going to say official goodbyes. This is all the time we have. Thank you so much, Sandy, for your time. This has been Cutting Edge, KSQD 90.7. I'm Galina Hale. Goodbye.